Finally, we have the last part of this webinar that includes Q&A session. For that, I will invite Engineer Ashish Sapkota to moderate the session.
So before we begin, I would like to thank our presenters today, Dr. Naveed, Mr. Ong, and Mr. Sabir, for their insightful discussion on performance-based design. This is a very hot topic that is going on over these few years. And also Dr. Naveed started with the newness in the PVD and what's coming next. But without further delay, I think we can directly go to the Q&A session. So there are a couple of questions regarding the PVD. And together with PVD, we also have a lot of questions regarding the codes and guidelines. And also there are a few questions regarding the breeze. So first, I plan to go with the PVD. And I think the first I would like to take one questions from the one of the participants. And I think Mr. Ong would be interested in this one. So it says that ASCE outlines specific height limits for various seismic procedures. So is PVD only effective for tall buildings, or it can also be effective for low-rise and mid-rise buildings?
Thank you, Ashish. Yes, PBD can be used not only for tall buildings, you can use for the low-rise buildings as well. Actually, PBD approach started with the low-rise building, mainly evaluate for the existing buildings in ATC 40 guidelines, and then finally it moves to tall buildings. So you can use any type of structures, low-rise or mid-rise or high-rise.
And to further, in addition to that one, there is another question that it says, so based on the codes ACI 318 and ASCE 7, if we follow that, then it says that it will guarantee the structure will have a certain performance level. So in that case, how do the PVD differ from the performance level specified by these ACI 318 and ASCE 7?
Following the code is, we assume that if we follow the code and follow the detailing rules, our building have that level of performance, but we did not explicitly check. For example, in the code, we designed for only one level of earthquake. We call it design earthquake. And then we scale down the base shear with the R factor and design the member strength capacity and provide the detailing according to the structural system that we selected. And we assume that if we follow those, our structure will be serviceable under frequent earthquake and it will not collapse under extreme earthquakes. But we did not explicitly evaluate. In PBD, we explicitly evaluate those levels of earthquake and structural performance. So PBD is more reliable approach compared to a code-based approach. And also if we do for the tall buildings design, there are some other effects like higher modes effects, and so code-based procedures, reduction of base shear by R factor may not properly capture those higher modes effects. So PBD is more reliable.
Can I add to that? Yeah. So I think what is more important here is not the overall performance of the structure, which is of concern, but primarily it is also identifying weak spots and local failures that can then trigger collapse. Because if you are designing generally, then we are treating the DC ratios of all the members equally as if they are equally important. But in reality, only few members are holding the structure down when the earthquake strikes. So we need to make sure that those particular elements have the right capacity with the correct forces on them and deformations on them. But the the omega factors that I showed and the R factors, they are applied uniformly, and they're applied uniformly to shear and moment and to all the members. But in reality, that's not the case. So for that particular reason, the nonlinear dynamic analysis will capture all the specifics of each component in each location and highlight if there is any local weakness. So that's the prime advantage.
Yes. So with this, maybe we can come to the one other question that I have from Samir. So he's asking that how can we ensure the results from the commercial software like ETABS can accurately represent the actual behavior of my structure. So I think maybe Mr. Sabir would like to give an opinion on this one.
Yeah, so actually, this is a very good question. There was a study recently conducted by, I believe it was NEHRB, and I would be happy to forward that study to the person who asked the question as well, where they compared the results of mathematical models with the actual large scale building tests were done in the labs. And from that report, actually, you can, and I'll just simply conclude it for the person who asked the question as well, is that you can see that at a very global level and up to a lot of the local results, the mathematical models were able to accurately predict uh, responses. Now, everything is not perfect. So, say for example, if you go and look at that report, they would conclude for you that most of the residual drift results that we get from our commercial softwares are actually unreliable compared to the test results from the labs, and the one that were predicted by the mathematical models were actually not compatible. And so when you read that report, you will be able to actually get a good idea as to how much accurate our programs are. And that report actually, from what I can conclude from that report, is that the commercial softwares actually do a very good job of predicting the response, not only the global response, but the local responses as well. Like if you see overall, the response or the commercial softwares do a very good job. Not everything is perfect, but what I would say is that we should not even assume that everything is perfect. This is all basically a judgment that we are making when we run time history analysis on our structural performance. As the same way you would do in the code-based design, because you don't really know whether the a structure will be able to stand an earthquake if you follow the code exactly. So, right. So it's all
That's
a judgment, and then so there are studies that have been done, and then we can go and refer to the study, the one that I mentioned, and I will be happy to forward the research report as well.
So with that, there is one more questions regarding to the stiffness modifier, the use of the stiffness modifier, and I think Dr. Naveed might be interested in picking up this one. So the question goes like this: that using the stiffness modifiers, so the section modifiers eventually reduce the inertia of member, which in turn reduces its reinforcement. So why do we do this? And please also could shed some light on it. So, sir, could you please go ahead with this one?
Yeah, I think the purpose of the stiffness modifier is not to reduce the inertia, but to reduce the stiffness. And the background is that the because as I mentioned in my presentation, that the service level loads are multiplied by a certain factor, and at that level we are expecting the structure to reach the yield point. So which means that if that it is reaching the yield point, some cracking must occur in the members in the concrete, which is in tension. So the structure, so this reinforcement will yield. So obviously the cracking will reduce the stiffness significantly. And if you look at any section, whether it's beam or column, under column the cracking is a little bit less. For beams it will be more. So the stiffness can reduce by almost 80, 90, 70% once the cracking starts, because then it's only the tension rebars and compression portion left there. And to accurately simulate that reduced stiffness at the level in which the results will be compared with the capacity and demand, because also factored and it's close to the design level. So we need to adjust the model. So that's why the stiffness reduction factors are modifiers are introduced in all various codes. There's a lot of discussion with the numbers and difference between different codes and all, and Ong has a better knowledge about specific numbers, but the background is like this.
So I think for the details we can go later on, but for the
Yeah.
overview, I think this is quite enough for us. And there is one question from Mr. Salman. So he's asking what is the difference between PVD analysis and time history analysis, as both of them are non-linear. So maybe Mr. Ong would like to shed some light on this thing.
PBD is a design approach, not the analysis. So in PBD design approach, you can use nonlinear time history analysis or nonlinear static analysis. So analysis are under PBD design approach. So for the tall buildings, normally we use the nonlinear time history analysis. We For the low-rise buildings, if you would like to use the nonlinear static analysis, pushover analysis, it is also okay. And even as I presented, in service level earthquake, we use the response spectrum analysis, linear analysis only, because we want to design the building to remain elastic. So depending upon the target performance level and structural response, you can choose the appropriate analysis method. So PBD is the design approach and analysis methods are under it.
Yes. So there is also one question regarding the difference between the PBD and the code-based design. So he wants to know what's the main difference between PBD and code-based design. And in addition to that, he also would like to know that the difference in the reinforcement consumption is large if we compare in between them. So will that largely affect the cost?
A difference in code-based design and PBD, that part we have explained when we start the Q&A session. But for the reinforcement quantity, in general, PBD can reduce the reinforcement compared to the code-based design approach, especially in the confinement reinforcement. If we check the deformation response, and if the deformation responses are small, in that case, we can relax the confinement. But on the other hand, for the strength capacity requirements for the shear response of the shear wall, that shear reinforcement can be increased compared to the code-based design. So, but anyway, we can effectively allocate the reinforcement in the members by using PBD approach. Based on our experience in tall building projects in high seismic zone, we have some saving compared to the code-based design. But if the building is located in the high wind zone and low earthquake zone, in that case, the doing PBD may not have significant reduction in the reinforcement because wind design may govern.
Yes, and there is the other question that so how about using the PVD for the wall bearing construction?
Bearing wall system, if we use with a flat slab, so in the high seismic zone regions, in that case, we have to design with the BBD approach. In that system, important ones are the punching shear of the flat slab because we do not have the frame for the gravity system. So the slabs and column connections are critical to avoid the brittle failure. That is one thing. And also bearing walls should have the enough ductility for the flexure loads, flexure response, and also the shear strength for the in-plane shear.
Yes, so there is one question regarding the use of the non-structural elements. So how do we do the PVD for non-structural elements? So maybe Mr. Savit would like to talk on this one.
Yeah, so basically, when you are looking at the non-structural components, you we will not explicitly model the non-structural components in the mathematical model, but you can always extract the global drifts, and this can be your pure shear drift or your uh, normal drift as well. And you can use that drift information to basically estimate, if you know your non-structural component capacities, whether there will be a possibility of non-structural component failures or not. And another thing you can also think about is that if you want to go even further and then evaluate the damage that you are going to get, or maybe estimate the cost of the non-structural damage that you are going to get from your analysis, then you can always go back and do your resilience-based design approach based on CMA P58, which allows you to basically evaluate the cost of the damage of the non-structural components, and the information that that process is going to use are going to be mostly your global results, such as your drift or accelerations in some non-structural components as well. So it depends upon what kind of a non-structural component that you are checking for. But again, as far as the mathematical model is concerned, you are not going to have any non-structural component over there, but you can use the global results from the mathematical model to evaluate the damages in your non-structural component always.
Yeah, Ashish, can I add to that? I think one exception to that, what Shabir is saying, is the masonry walls. If you are doing a building which has masonry walls and it's a low-rise building, in that case, actually we are required to model them, even though they are non-structural. In our what Shabir is mentioning is mostly related to tall buildings where it is not necessary. But for low-rise buildings or mid-rise buildings, if the masonry walls are being used as non-structural, they should be modeled because they have significant impact on the response of the buildings, especially the nonlinear response, and also they affect the initial stiffness substantially, and they attract a lot of seismic demand. And then later, when the walls break, then it is shifted back to frames. So those walls can be modeled by equivalent strut model. So there are ways to model using a strut element with a hinge in it, axial hinge in it. And there are many procedures available to do that. So in general, partition masonry walls in low-rise, mid-rise buildings should be modeled, while in tall buildings, they might be ignored.
Let me move to the other question. So it's related to the reduction factor due to the ductility of the structure. So the person would like to know that is it possible to use the same reduction factor due to the ductility of a structure for a dynamic wind load the same way as for a seismic action? So maybe Mr. Ong would like to take this one.
Okay. So for current practice, we do not use the reduction factor like R factor in the wind design. And normally we design the wind loading, ultimate wind loading. The structure has to remain elastic under that ultimate wind loads. But wind performance-based wind design approach, people start using in very tall buildings. So in that approach, we allow nonlinearity in the structural system to some extent. Not very large nonlinearity like seismic loading, but to some extent, we allow the yielding of some structural components. In this approach, we have to run the nonlinear time history analysis for the wind loading. But we do not use the reduction factor like R value in the linear analysis for the wind loads. But this one this approach is still evolving stage.
So there is some related questions to this one. So it says that when using the overstrength factor, should we apply the reduction factor and supporting element in code based? If yes, which book or code specifies it?
It is ASCE 716, section 12.3.3.3, elements supporting discontinuous walls or frames. So in that clause, it mentioned about the application of overstrength factor.
So there is one question that he's asking if there is any limit of maximum steel strain in steel structure without a problem of local instability for a compact steel section.
Okay, I will take that question. So in ASCE 41, it also has the acceptance criteria for nonlinear procedures for the steel sections. So in that criteria, it checks the rotations or axial deformations of the steel members. So instead of checking the strains, it checks the rotation, which already consider the local buckling effects or other effects based on the laboratory test results. So you can use that criteria and provide the nonlinear hinges for the moment rotation hinges or axial force deformation hinges to check the nonlinear response instead of checking using the strain limits.
So the one question is, Samar is asking which version of ETABS has all these options that Mr. Savir showed in the presentation.
Yeah, so the options that I showed actually should be available in ETABS 22, but I believe most of the options are available in ETABS version 21 as well, except for maybe general wall, which I believe came in version 21. Yeah, 21, 22 should have everything.
Thank you. So Mohammed is asking that concerning the complexity and high knowledge domain, there may be a potential disagreements over performance targets. Do we need to move to standard developments for PBD? If then, what's the future against the standard codes like IBC or country-specific building codes? Maybe Dr. Naveed can spare some time on this one.
Yeah, I think yeah, that is actually a very good question, and that is there is both the necessity for these guidelines. Normally, they are called guidelines, not codes, because as the procedures evolve, more and more information is coming into light, and then more and more guidelines are now incorporating these provisions into their body. In fact, the next webinar that we will discuss is related to ACI, which is also moving gradually in this direction. So, in my personal view, is that gradually most codes, the real building codes, will start adopting the PBD procedures. First, probably through the annex, and then finally getting into the body, providing as an alternative method. I don't think it will be the only method they will provide, but they will specify as alternative method, and people can use either the procedural or the prescribed or the other one. So that's what I think will happen to the traditional codes, because they have to be relevant, and gradually they're going to adopt this one. And we are already seeing happening in Eurocode, we're already seeing happening in ACI code. But of course, the specific guidelines for performance-based design, I think, will get more specific, in the sense that now we have a whole bunch of guidelines for tall buildings. Similar guidelines are being developed for bridges. Similar guidelines will be developed for other structures, because nonlinear analysis and performance-based evaluation is very specific, structure specific. So it's not easy to generalize them. So I think, in my view, the future will be more structure type specific guidelines for PBD, while the general codes start to include more of the PBD concepts and principle as their basis or as alternative procedures. So the guideline and the code will be on the same page in coming years. You want to add something on that?
As Dr. Naveed mentioned, codes and guidelines, they start adding the PBD approach in ACI. You can see in the appendix, and also in ASCE 7, it also mentioned about the nonlinear analysis, time history analysis procedures with the classification of the actions, critical, deformation control actions, force control actions, and so on. So they start adding the PBD approach as an alternative procedure in the design guidelines and the codes. And another thing is in the local country building codes like Japan or China or India. So they also have their own guidelines for use application of PBD, especially in the tall buildings. Sometimes they refer to the other international PBD guidelines. So PBD is moving forward and adding in those documents.
That's the way forward. Then I think also there are things coming up for AI like ChatGPT, Gemini, and all other things. So maybe we can train and we can have more comprehensive kind of approach in the near future. So I think with this we can conclude this session for Q&A. And the remaining questions that we have in the chat box, we will respond to them separately via email. And also, if it is too high, maybe we can also conduct some other seminar to respond to those. So for now, I think thank you very much, all the speakers. And now I would like to hand over to Hamad. Over to you, Hamad.
So thank you, Engineer Ashish, for moderating the Q&A session. Hopefully, most of the questions has been answered. So before closing, I would like to thank Dr. Naveed Anwar, Mr. Ong, and Engineer Shabir for sharing your expertise And also, I would like to thank all of our attendees for joining us today. We hope you find today's session both informative and inspiring. If you have any questions, please visit our website www.csibangkok.com or reach us out at learning@csibangkok.com. So with this, we are going to finish this session. So stay curious, stay inspired, and keep innovating. Have a great day.